Welcome to Session 24. Modeling questions combine reading with math. Today, we decide whether a situation is linear, exponential, or quadratic. Then interpret each parameter in context. For equally spaced inputs, constant differences suggest a linear model. Constant ratios suggest an exponential model. Check differences first, then ratios. If first differences are not constant, look at second differences. Constant second differences indicate a quadratic pattern. Build models from the initial value and the change rule. Linear models add a rate. Exponential models multiply by a factor, and the exponent must count the correct periods. The base of an exponential is a multiplier. 1.06 means 6% growth. 0.88 means 88% remains, so the decrease is 12%. For break-even, set the two models equal. Here, 30 plus 5x equals 8x, so the plans cost the same at 10 items. Your turn. A quantity starts at 1200 and decreases 10% each period. Pause and write the model after t periods. A 10% decrease means 90% remains each period, so the base is 0.90. The model is 1200 times 0.9 to the t. Session 24 recap. Constant differences mean linear, constant ratios mean exponential, and constant second differences mean quadratic. Exponential bases are multipliers, and break-even means set the models equal.